Hello and welcome to Unit 2, Variables and Expressions. We're on section titled 2.5, Translating Words into Math Expressions, and we're working with Pizzazz page 10. Please double check that your name and date are on this particular sheet, here and here, and we'll move ahead. So the first thing to talk about is the vocabulary. We're going to talk about some common word puzzle translations. So when we talk about word puzzles, we're really talking about words, English phrases rather, that we want to translate into math. So let's take a look at our operations that we have together. So we work with addition, subtraction. We also work with multiplication and division in our basic word translations. So of these, we're going to add in some fairly frequently used words that mean addition, that mean subtraction, that mean multiplication, and that mean division. So let's start with the addition. So here we go with sum, plus, increased, more than, and combined. So these 5 words are not the only 5 words, and there is a word note sheet that we'll hand out in class that is a graphic organizer to help you with these. So when we take a look at addition, again, some of the main ways to go about this include sum, plus, increased, more than, or combined. Now let's take a look at some subtraction. So less than is a word for subtraction. Decreased is also a word for subtraction, decreased by rather. Fewer and difference. Moving ahead on into the multiplication words, we're going to have examples of each way this goes out, what this might look like in particular words, but I just wanted to do a quick overview. So multiplication could have words such as times, products, increased by a factor of, twice. Often we think of multiplication as making something bigger, and when we take a look then, division would be making something smaller. So again, multiplication words that we're taking a look at are times, product, increased by a factor of, twice. We can also incorporate multiple other words, including multiple, also triple, quadruple, certain instances in which we might have multiplication specific to a particular number. Now let's take a look at division. So some words for division could be quotient, per, half, so if you're taking half of something, or the ratio of. If we were talking about the ratio of 2 items, we are essentially talking about division. And you might look at that more when we take a look at proportions. So some words for division, again, these are making something smaller by dividing, and we have words like quotient, per, half, and ratio of. Now our key concepts we're going to add into the method for translating math expressions. So this is going to be our method for translating math expressions. And when I use this method for translating math expressions, my first thing to do is to identify the variable. And we talk about variables as things such as numbers, unknown items, age, price of something that we don't know. Variable could be anything that we're not quite sure about. The piece that we're trying to find. The next thing that we are looking for is to identify keywords of what operations we might be working with when we take a look at this English translation. And the operations above are not the only words that will associate with those particular operations. We also can have words that mean something separate from addition, subtraction, multiplication, and division, such as the square or square root, or to a power of. So there are others that organize these addition, subtraction, multiplication, division are the main operations that we work with. Now the third item that we're going to take a look at is to translate and check the reasonableness. So once we translate an item, particularly an English phrase, we want to make sure that what we wrote for our math expression makes sense, that it works with the situation that we've been talking with. So that reasonableness check is a really nice piece. Let's take a look at a couple of examples that give us some more basic operations and then some that will give us multiple operations. Now a basic operation is something that might look like 5 more than a number. Now the number is the thing that I don't know, so that's my variable that I'm going to be working with. And the most common variable we use is x. X is no longer something we use for multiplication because it is a variable in algebra. So in this case, the number is our variable, and we're trying to find 5 more than the number. So in this case, more than means to add, and we're going to have x plus 5 because we start out with this unknown number and add 5 to that unknown number. The next thing we're going to talk about, another example, is 6 times a number. So if I have the phrase, the English phrase, 6 times a number, times means to multiply, and we're going to go ahead and write 6x. Whoop. Let's hold off on the next example here. So we write 6x without any operation shown. The invisible operation is multiplication when we work with algebra. You can, in fact, write this same piece as 6 times x with a little dot in there. Let's see if I can make the dot any bigger. There. 6 times x. Or you can also use it using parentheses. So 6 parentheses x. Those are also some ways in which you can take a look at 6 times a number and still have it be there. Now, I could use a different variable if I don't really like x. X is just the most common variable that we use when we work with algebra. Alright, our next example is going to be 9 less than a number. And when I take a look at 9 less than a number, less than is the piece that I'm taking a look at. Still, the number is my variable that I don't know, so I'm going to have probably x to indicate that number. And less than is going to work on that subtraction. So we're going to write x minus 9, and we're going to notice that this is not a direct translation. I don't write, when I say not a direct translation, I don't write the 9 first, and then the subtraction sign, and then the x as the number I'm trying to find. Because really, I start out with the number I don't know, and I take 9 away from that number, which is why we want to have it say x minus 9 as opposed to 9 minus x. So don't write it as a direct translation when we're using the word less than. Next example we'll take a look at, and the last on this particular page, is 7 decreased by a number. Now when I take a look at 7 decreased by a number, my variable is still the number that I don't know, and decreased, when I take a look back up at the top of my vocab that I just added, decreased by is a way of saying subtraction. Now in this case, we need to be careful because up above I said for subtraction that it's not a direct translation. But here we need to figure out, am I taking 7 away from a number, or am I taking the number away from 7? Now in this case, when we talk about decreased by, I start out with 7, and I'm going to subtract the number from it because it's decreased by this unknown number. Do be careful when we talk about subtraction. There are situations when it's not a direct translation, such as the one above, and situations when it is a direct translation. So be careful. We're going to take a look at some more advanced types of English expressions that have more than one operation. So please add your section title to the backside. We have 2.5 translating math expressions. And these examples are going to be when we have multiple operations within an English phrase. These are going to be situations that will be a little bit more complex and perhaps have multiple operations such as addition and multiplication, or subtraction and division, or any combination of them. So let's get started on our first example. We're going to take a look at the idea, the English phrase of 7 less than 3 times a number. And here, the number is my variable, and I do in fact have 2 different phrases that specify different operations, less than and times. Less than is subtraction and times is multiplication. If I take a look at this, 7 less than is going to be like subtracting 7 from something. And the something I'm going to subtract it from is this 3 times a number. So I'm going to write 3x in order to indicate that 3 times a number. Now less than is one of those in which we don't have a direct translation, so make sure you're organizing that particularly carefully. Another example we'll take a look at is what if we have twice the sum of 5 times a number and 8? Well, there's a couple of pieces playing in here. We have the identification of twice. We also have sum and times. So we need to be particularly careful about this. Twice is the same thing as 2 times. Sum is an addition, and we kind of haven't figured out what we're adding yet. So we keep reading and say that the sum, or the pieces we're adding together, are 5 times a number and 8. So I'm actually going to highlight the 5 times a number and 8 to say that's what I'm adding together. If I take a look at 5 times a number and 8, I can kind of put that in parentheses because that's the first bit that I need to do first. And I'm going to have the 2 times as something that's going to be on the outside because it's 2 times a sum and I don't know what the sum is yet until I figure that out. So inside the parentheses, I'm going to write the 5 times the number, so 5x and the 8. So again, our answer is going to be 2 times the quantity of 5x plus 8. Figuring out what goes inside the parentheses when we're multiplying all of these pieces can be a bit challenging. Practice is really the main key in helping you get there and feel very comfortable. We have 2 more examples that we'll show you together and then 2 to try on your own. Let's take a look at our next example that says 9 less than half a number. So in this case, it looks like we have a couple of pieces for less than, so we're going to be subtracting. And we're talking about 9 less than, so we're going to be subtracting 9 from something. The next thing that we notice is that we have half. And half of a number, which is the variable that I don't know, is going to be written as x over 2. Because when I take half of something, I really am dividing it by 2. It's a really good way of understanding half. So half is division by 2. Another example we're going to take a look at is if we had 7 meters shorter than twice the length of x. So the length of the piece that we don't know is the length, and they actually tell us to use x, so length x is the piece that we're not sure about. And we have a couple of ideas here. We have 7 meters shorter than it, and we have twice the length. So 7 meters shorter than is going to be the minus 7, and the twice the length is going to be identified as 2 times x, or 2x as we often will refer to, 2 times something. From here, we have a couple of problems you're going to try on your own. So do your best on these. Again, it is the attempt that you are getting credit for. And your next piece for the try on your own is you're going to have 7 times a number increased by 4. Now beware here, I want you to figure out what it is, the variable that you're trying to identify, along with what the operations are that will be working around this variable. We'll check in with you at the beginning of class on these 2 problems. The second problem for you to try out is 8 less than 3 times a number. So 8 less than 3 times a number is the second try on your own. Make sure you're indicating what the variable is and what the operations are that you're trying to work within. Thanks for your time. We'll see you in class.